What happens when a honeybee is trained to detect bombs? Introduction. The fascinating intersection of nature and technology. In the search for innovative solutions to complex security threats, humans often turn to technology and scientific advancements. However, sometimes the most unexpected sources of assistance come from the natural world. One such surprising partnership is the collaboration between humans and honeybees, creatures that have long fascinated scientists for their ability to communicate, navigate, and perform intricate tasks within their colonies. Today, this small insect is being trained for an entirely new mission: detecting explosives. At first glance, the notion of a honeybee trained to detect bombs may seem both unusual and improbable. However, recent research and real-world applications have shown that honeybees, with their exceptional olfactory capabilities, can indeed be trained to sniff out explosives with remarkable precision. This technique, which falls under the broader category of biodetection, has the potential to revolutionize how we approach the detection of hidden explosives and landmines. But how does a tiny bee, with its minuscule brain, come to play such an important role in modern security efforts? What does this partnership between nature and technology entail, and how does it work in practice? In this exploration, we will delve into the science behind training honeybees to detect bombs, the process of conditioning these insects to recognize explosive scents, and the potential benefits and challenges of using bees in bomb detection operations. The science behind honeybees' exceptional sense of smell. To understand how honeybees can be trained to detect explosives, it is essential to first recognize the remarkable sensory abilities they possess. Among all insects, honeybees are known to have one of the most sophisticated and advanced olfactory systems. Their sense of smell is hundreds of times more sensitive than that of humans, making them ideal candidates for detecting odors, including explosives. Honeybees rely heavily on their sense of smell for several critical functions, including finding food, identifying potential threats to their colony, and communicating with other bees. Their antennae, which are equipped with an array of chemoreceptors, enable them to detect specific odors at incredibly low concentrations. When a bee encounters a scent, its brain processes the information and can even distinguish between different chemical compounds based on their molecular structure. Researchers have discovered that honeybees can be trained to respond to specific smells through a process called classical conditioning. This process involves pairing a neutral stimulus, such as a particular odor, with a reward, such as food. Over time, the bee learns to associate the odor with the reward and will respond to the odor by performing a specific behavior, such as extending its proboscis, feeding tube. This ability to learn and respond to specific scents is what makes honeybees such powerful tools for bomb detection. Training honeybees to detect explosives. The process of training honeybees to detect bombs begins with conditioning the bees to recognize the unique chemical compounds found in explosives. The first step is to introduce the bees to the target odor, such as TNT, trinitrotoluene, which is commonly found in landmines and other explosives. Researchers use a method known as classical conditioning to associate this odor with a positive reinforcement, such as a sugar solution. During the conditioning process, bees are placed in a controlled environment where they are exposed to the explosive scent. As they encounter the odor, researchers offer the bees a small drop of sugar water, which serves as a reward. Over time, the bees begin to associate the explosive scent with the sweet reward, and they learn to respond by extending their proboscis in anticipation of the food. This behavior, known as the proboscis extension reflex, PER, is a clear indicator that the bee has learned to recognize the scent of the explosive. The key to the success of this method lies in the bee's ability to remember and recognize specific odors. In fact, honeybees are known to have impressive memory capabilities. Once the bees have been conditioned to respond to the explosive odor, they can be tested to determine how effectively they can identify it. Researchers can introduce a variety of scents, both familiar and unfamiliar, and observe how the bees react to each one. If the bee shows a positive response, i.e., extends its proboscis, when exposed to the explosive scent, it confirms that the training has been successful. Friends, so far you have learned facts which probably have been beyond normal imagination. There is a lot more about honeybees in this video, so please watch it till the end and you will learn a lot more about these tiny bugs which will amaze you about even future prospects of utilization of bees. Honeybee behavior in bomb detection missions. Once honeybees have been successfully trained to detect the scent of explosives, they can be used in real-world bomb detection missions. Honeybees are typically placed in specialized devices, such as small portable containers or backpacks, which are equipped with sensors that allow researchers to monitor the bees' responses during a detection mission. When the bees encounter the target odor, their proboscis extension serves as an indicator that the explosive scent is present. One of the advantages of using honeybees for bomb detection is their agility and ability to cover large areas quickly. Unlike traditional bomb detection methods, such as metal detectors or trained dogs, bees can navigate tight spaces, fly at high speeds, and cover large distances with minimal effort. This makes them particularly useful for detecting landmines or other explosives that may be hidden in areas that are difficult to access. Additionally, bees are able to detect very low concentrations of explosives, making them highly sensitive to even trace amounts of bomb-making materials. This level of sensitivity can be crucial in detecting hidden explosives that might otherwise go unnoticed using conventional detection methods. The advantages of using honeybees for bomb detection. While the concept of using honeybees for bomb detection may seem unconventional, the benefits of this approach are undeniable. Some of the key advantages of using bees for bomb detection include: 1. Cost-effectiveness. Traditional bomb detection methods, such as trained dogs or robotic systems, can be expensive to train and maintain. 1. Honeybees, on the other hand, are relatively inexpensive to work with and require minimal resources for training and care. 2. Speed and efficiency. Honeybees are capable of covering large areas quickly, allowing for faster bomb detection operations. 2. Their ability to fly at high speeds and navigate through difficult terrain makes them ideal for searching areas that may be difficult for humans or machines to access. 3. High sensitivity. Honeybees' exceptional sense of smell makes them highly sensitive to the presence of explosives, even in trace amounts. 3. This heightened sensitivity is crucial in identifying explosives that may be buried or hidden from view. 4. Non-invasive. Unlike some other detection methods, such as X-ray machines or metal detectors, using honeybees does not require any physical contact with the environment being searched. 4. This makes the process non-invasive and less likely to disturb delicate ecosystems or cause damage to the surrounding area. 5. Minimal environmental impact. Honeybees are part of the natural ecosystem, and their use in bomb detection does not require the destruction of habitats or the use of harmful chemicals. 5. This makes them an environmentally friendly option for sensitive areas. Challenges and limitations. Despite the many advantages of using honeybees for bomb detection, there are also several challenges and limitations that must be addressed. Some of the key challenges include: 1. Environmental conditions. Honeybees are highly sensitive to environmental conditions, such as temperature, humidity, and wind. 1. Extreme weather conditions or changes in the environment can affect their ability to detect explosives effectively. 2. Training and maintenance. While honeybees can be trained relatively quickly, the process requires ongoing maintenance to ensure that the bees retain their ability to detect explosives. 2. This can be time-consuming and may require frequent retraining sessions to keep the bees responsive to the target odors. 3. Limited operational range. Honeybees have a relatively short flight range, typically a few kilometers at most. 3. This means that they may not be suitable for large-scale bomb detection operations in remote or expansive areas. 3. Additionally, their ability to cover such distances can be limited by factors such as fatigue or environmental conditions. 4. Ethical considerations. Some critics have raised ethical concerns regarding the use of insects in bomb detection, particularly regarding the potential for harm to the bees during training or operational missions. 4. While the overall impact on bee populations may be minimal, the use of living creatures for such purposes raises important ethical questions. 5. Accuracy and reliability. While honeybees are highly sensitive to odors, their responses are not always predictable. 5. There may be instances where the bees fail to respond to the target scent or mistake other odors for explosives. 5. This means that bees must be used in conjunction with other detection methods to ensure accuracy and reliability. Future prospects. Beyond bomb detection, the use of honeybees in bomb detection is just one example of how the natural world can be harnessed to address complex challenges. As research into biodetection techniques continues to evolve, there is potential for honeybees to be used in a variety of other applications, such as detecting chemical pollutants, monitoring environmental changes, or even identifying diseases in plants or animals. In addition, advances in biotechnology and genetic engineering may offer opportunities to enhance the capabilities of honeybees and other insects. For example, researchers are exploring the possibility of genetically modifying bees to make them even more sensitive to specific odors or to improve their ability to navigate challenging environments. Conclusion. A small insect with big potential. The use of honeybees in bomb detection is a fascinating and innovative application of nature's remarkable capabilities. By leveraging the bee's exceptional sense of smell and ability to learn through classical conditioning, scientists have developed a powerful tool for identifying explosives with precision and efficiency. While there are challenges to overcome, the advantages of using honeybees in this field are clear, and their potential to contribute to global security efforts is immense. As we continue to explore the untapped potential of the natural world, we may find that nature itself holds many more solutions to the problems we face. The humble honeybee, with its remarkable abilities and unique skills, serves as a testament to the incredible possibilities that arise when we look beyond conventional technology and work in harmony with the world around us.